Hello everyone. In today's lecture, we will learn how to use source transformation to perform circuit analysis. Why make use of source transformation? This is because it helps simplify the circuit, making it easier to combine elements like resistors. Here we have an independent source transformation. A voltage source in series with a resistor is transformed to a current source in parallel with a resistor. This is done using Ohm's law. Taking the voltage source and the resistor values, we can find the value of the current source. The resistance value stays the same. It is important that a voltage source is in series with a resistor to be able to transform it to a current source in parallel with a resistor and vice versa. Also note the direction of the current and voltage source. If the voltage source is placed in the opposite direction, the current source will also be in the opposite direction, which will be the same direction of the voltage source. It is the same if the current source points in the opposite direction and you want to transform it to a voltage source. The same concept applies to dependent sources. We will change a voltage source to a current source that is dependent on an element value. Now let us use what we have learnt in an example. In this example, we will find I0 in the circuit using source transformation. I0 is the current of resistor 3, the 7 ohms resistors. First, we should take a look at the circuit to see what we should combine and transform to best find our answer. Now we can see that resistor 5 and resistor 4 share a node and are in series. They are combined to form a 5 ohms resistor. It is also seen that resistor 1 and resistor 2 share 2 nodes, so they are in parallel. The combination gives a 2 ohms resistance value. Now let's take the approach of transforming the resistor Req1 and the current source I1 since they're in parallel. Using Ohm's law, we can transform it to a voltage source of 20 volts in series with a resistor of 2 ohms. Now there are two voltage sources in series flowing in the same direction. They can add up to give a single source of 15 volts. Remember, we are supposed to find the current of resistor 3. Looking at the circuit right now, there are several approaches to do that. Let's look for the easiest way. We can transform voltage source 1 and resistor Req1 to a parallel combination of a current source and a resistor. This turns the whole circuit to a parallel combination of elements. Most importantly, resistor 3 will remain intact. Now, two current sources are in parallel and can be combined to form a single source. They both flow in the same direction, so they add up. Also to note, voltage sources in series add up while current sources in parallel add up. Finally, we have a single current source in parallel with 3 resistors. We are looking for I0, which is the current flowing through resistor 3. Easiest way to do this is to use the current division equation to find the current because everything is set up for it. At the end, we found the current to be 1.78 amps. Okay, now that is done, we will do another example that contains a dependent source. In this example, we will use source transformation to find Ix. Ix is the current of resistor 2, the 10 ohms resistor. Let's see how to best find it. We can either transform the current source on the left and make a series circuit or transform the voltage source on the right and make a parallel circuit. Let's do the latter since we are looking at dependent sources now. As you know, we will take the dependent voltage source in series with resistor 1 and transform it to a dependent current source in parallel with resistor 1. Looking at the circuit now after the transformation, we can find the current Ix using node voltage analysis. Each parallel branch has a current we can use for the analysis. Current source I2 depends on the Ix current, which is the current of the 10 ohms resistor. We can find that using Ohm's law. Now we can find the KCL at node V. This helps find the value of node V since it's the only node we have to find. Now that we found the node voltage value, we can find the value of Ix. Ix was found to be 7.059 milliamps. With that marks the end of the lecture. Now you can see how to use source transformation to simplify your circuit or at least transform it to make use of a better analysis method. Well, I hope you all enjoyed your time. Goodbye. Till next time.